Hello everyone, in this video I will show you how to use Node-RED on KinCony Server16 Raspberry Pi IoT gateway so that you can manage all Server16 as a hardware resource such as digital input, digital output, and the PWM output, and some RS485, RS232 interface. Okay, let's look at how to do with it step by step. Okay, now you can see this is KinCony Server16. It's a Raspberry Pi controller. In this video, I will use this controller. I have connected with my monitor and by this HDMI, and this is the mouse. And you can see the monitor one is for this one, and this is computer, and this computer I will use this computer running the Node-RED. So I will test by this device for you to use the Node-RED. So at the first, let's look at the hardware. This is KinCony Server16. You can see it's a Raspberry Pi controller. You can see it here. This is Raspberry Pi CM4. And also can use the 4G module if you install it. And there are some digital input and free GPIO. And this relay output and PWM and RS485 and RS232. And this is SIM card, HDMI, and some USB device. So you can see it here. We will use this Node-RED to manage, and just this is a demo, can manage all hardware resources. And this Node-RED, you can see I have created the folder you can download from our web page. Right here, you can see you just download this folder, unzip it, and this is JSON file. And the first, I have already installed the Raspberry Pi image to the SD card. I have used this image. This is with desktop and with the remount software because that already have integrated the Node-RED on the install package. So that will be directed to you and will have the desktop. Okay, let's look at my computer. This is Raspberry Pi OS. And I have used this mouse, have connected this Raspberry Pi, just as this. So you can see, if I start up, and you will see this menu right here. And this is a program that have Node-RED already installed. So you just click, it's very easy. Click, and this window will show it here. So this will start the Node-RED. So we can use this IP address and the port, visit this IP address port in any computer, just in the same local network. So now I will use this, my computer, and this is the Node-RED, and you can see I can refresh. So this I have already import because I have import and select a file to import. I have already do this, just download from our KinCony website, just this file, unzip it and import. But after import, you can see if you deploy it, there are many errors because this is new for the Node-RED. So you need to install some components manually. At the first, you can see we have used this MCP 23017. This is I2C chip for external 16-channel output and 16-channel input. So we have used this chip to extend the relay and extend the digital input. So the first you need to install this node, just input MCP 23017. You can see just this one because I have already installed. You need to install this one, and then you can choose close. And the next, you will see so many errors. Many of these errors because can't use I2C and can't use some serial port. Because you can see this is serial port. This is for 4G. And this is for RS232, not connect, and not connect. So we need to enable this serial port and enable I2C bus on Raspberry Pi. And how to enable it? So It's also very easy because we have used the desktop of Raspberry Pi. You can click and this one, and you will see Raspberry Pi configuration. And you can see this window. We can add here and click interface and enable this I2C. You just enable it. And the server part also you need to enable it. And this, pay attention, this must to disable. This server console, you need to disable it. So I can click OK, and we'll restart the computer. You can see if you press yes, and this Raspberry Pi computer will be restart, and we can reopen this node-RED again. So this is my USB to RS485 interface. I will test with this RS485, and this I will use test the PWM output frequency. So we just wait for this computer start up. Okay, you can see it start up. When it start up, and you can see the sound, because you can see already is working, because I have already installed the node-RED. So you can see that is enabled I2C. So this time is working. This is 16-channel relay output LED indicate. And we can click this one. And this time I can click node-RED again. Okay. And also you can see I can use this IP address to visit. Okay, let's look at my computer. And this time you will see, you can see this is connected, and this is connected, and this also is not connected because we need to enable multi-server port. And this time you can see that is, if I refresh, you can see turn off, turn on relay. So this is working. You can see the sound. Okay. And we need to slow this server port for 4G and for this RS232 because the default only enable the first one server port. So we need to enable the additional server port of the CM4 module. And we can look at here this topic, how to enable Raspberry Pi CM4 additional UART server ports. And we just need to add this config file and to add this command. So you need to change the SD card. And now you can see I need to power off my server16 because we need to change this SD card. So I power off. You can see all power is off. And now I can get out the SD card and put this SD card to my computer. And you can see it is a config.txt file, just this one. We can edit it. And at last, we just need to copy this 4 command. Copy and paste it here. Then you can choose save and click close and eject. Okay. Now I will get my SD card and insert to my server16. Okay. And at last, I need to power on. Okay. Now just wait this server16 start up. Okay. You can listen to the sound, and this time you can see all server port is connected. So this time we have enabled all server port on the CM4. Okay, now the all hardware and the software is ready. So you can see if I press reply, you can see no any error. So this is ready to use. Now I will begin to tell you how to use this node RED. And the first one, that is test the 4G module. So if you have this 4G module, you can connect it to the server 16 so that you can manage AT command, send AT command and receive AT command by yourself. And this is just a test. You can see if you double click and you will see this AT command at here. And this one just /n, just a end for the AT command. So this, if you click, that will send by this server port to the 4G module, because now my server 16 is without not install the 4G module. If you click this one, and this will feed back at the debug window at here. Okay, let's test the second one, this IS232 test. If I double click, that will send a string command, IS232 test. If I can click, but you can see this is nothing, because we can use a cable and connect with the IXT and the TXT together. And you can see this IS232 that have TXT and IXT. So we can test it just like this. That means I have shot the IXT and the TXT. So you can see if I click this one, you can see at this window that will display IS232 test, because I have used this twice and shot the IXT and the TXT together. Okay, this is test the IS232 interface, and now we can test the IS485. Just use this one. And you can see that is IS485 A and B. So this is A and B, this is USB IS485 adapt. So I will use this connect with my computer. I can open this software. This is for third port debug. And you can see that is auto detect the USB to IS485 adapt. And the bandwidth just as same as this one. This one 115 to 00. So it's okay. We can click. And this time you can see if I send the command 112233, you can see I press send, and you will see it here. And you can see we can set by this ask date send stream. So you can see if I click this one, and you will see that is received by the node RED 112233. And if I click this one, IS485 test, I click, and you will see that have received it here. So we can get out of this window, and you can see just it here. You can see I can press this one that is sent to my adapt, and I can click send. That is feedback to node RED. So that is send and receiver. So these two paths is correctly. Okay, and this is IS485 interface. Let's look at the next one. You can see the speak, because in our board this is a speak for send alarm sound. You can see if I click, that will speak on. If I click speak off, so that will be off. So you can see I can use it for alarm sound. You can see on, off, on, off. So that is for speak alarm for you to use. Maybe some temperature is high or temperature is low, so you can use your speak. And you can see this is IF receiver and IR receiver. So if you have a IR remote, you can see such as this IR remote or wireless remote, so that when receive the signal, that will be changed 010101. That means decoded wireless signal. And the next one is the PWM output, and this will be used for output the PWM signal. So we'll change your motor speed, and we'll change your light brightness, so can change the level the frequency level for Raspberry Pi. So you can see I can double click and you will see this. We have defined the GPIO which PWM output, and the frequency is 30 Hz. And another channel PWM output that I have set the 20 Hz. You can change by yourself. And this just have two PWM output. Let's test it. And you can see this have PWM output 0 and 1, just two channel. And this is ground. I have connected with my machine, and I can open it. And let's test the output frequency by this machine. Okay, let's test the channel 1, just PWM output 0. So you can see I can connect with this one. This one is channel 0, PWM 0. And you can see they have nothing. And now, because I will click this one, I will triangle this one. You can see I can click, and you will see this become 1, so that is enabled. And let's look at this PWM output again. So you can see this is 0, and in this time you can see my machine display that have you can see this one 29 Hz, 29.999 Hz. So this is output 30 Hz. So it's very correctly. Okay, this is PWM channel 1, and let's test it. This one is another channel. So I can use mouse, click this one, just click it. Okay, and you can see this is turned green. And we can test this another channel. You can see just this channel. This is channel 1. So I can test it here, and you will see in my machine that is 19.99999 Hz. So that is almost 20 Hz. So that means the node red is controlling this different frequency by the PWM output. Okay, so this is Raspberry Pi node red have managed this two channel of PWM. You can connect to your PWM driver. And the next we will see this GPIO 16, 17, 20, and until at here. So that is for free GPIO. We have used this, read this state. You can see that state all is 1, 1, 1, 1. So we can toggle for this state and see this node red state will be changed. Okay, let's turn off. And this time I also will use this cable because this cable is ground. So I use this cable and shut this free GPIO, and you can see that is free GPIO have print. This is 16, this is 17, and this is 20 and 21. So I can shut for this 16 and just this screw. So you can see if I shut at this one, and you will see the node red is become 0. So you can see at here that is become 0. So this is you can use this GPIO for binary sensor, or use this GPIO for one-wire sensor such as DS18B20 temperature sensor or humidity sensor, or can connect with this free GPIO. Okay, let's look at the next. And at here you can see that is for relay output, and this is for input. And you can see this time I can change this relay. You can see turn off, and this one you can see this one LD1 channel 1 is off, and this you can see that is turn on. So turn off and turn on, just used by this inject. It's very easy. So you can see I can turn off 1, 2, 3, 4. So this you can see this 4 channel LD is off. And also you can see this 16 channel input, the input 1, 2, 3. So I have used this input and connect with output directly. So if you use a cable that is short and disconnect, so that the relay will be changed. So let's test it. And you will see that is for digital input, the 16 channel input, because this we have designed for long distance circuit inside of the PCB. And this is also can use for digital input, but this is free GPIO. So not only you can connect with my binary sensor, but also you can connect to one-wire sensor. So this is not for long distance, but this is for long distance. So you can see if I short for this channel 1 with the ground. So you can see if I short, the relay is off. I release, relay is on. So that can let the input and work with the output, the relationship. So this can set by node RED. Okay, so you can see there are 16 channel input and 16 channel output. You can use by yourself, and just all this hardware, how to control, and this demo node RED follow, you can use it so that you can make your own logical and make your own automation by the node RED. It's very easy. Okay, thanks for watching.